Venice, a city like no other, has long captivated the world with its romantic waterways and timeless charm. But beneath the surface of this Italian jewel lies a profound struggle against the relentless forces of nature. The delicate equilibrium between land and water that defines Venice is under siege. Rising sea levels and receding foundations have transformed picturesque streets into heavily flooded passages, threatening the very existence of this historic marvel. Yet, Venice refuses to surrender. In the face of adversity, the city is poised to make history once again, on this occasion via an audacious megaproject. Introducing the MoSE, a visionary defense system forged with a hefty $7 billion investment. This monumental project merges cutting-edge technology with centuries-old craftsmanship, a testament to Venetian ingenuity. The historic arsenal, once the heartbeat of Venice's maritime power, now pulsates with renewed vigor. Here, skilled hands and state-of-the-art machinery fashion colossal barriers, each piece meticulously designed to withstand the relentless Adriatic waves. However, this project is not without its controversy. It has been decades in the making, has required considerably more funding than originally forecasted, and been marred by corruption and environmental protestations, with aspersions also cast over its long-term sustainability. So what is the MoSE? How is it going to help Venice adapt to an ever-changing climate, and can other similarly threatened coastal cities learn anything from its implementation? If you enjoy our videos, please like, subscribe and hit the bell. It helps us keep delivering great content like this. Venice, the jewel of the Adriatic, a city built on water, has long held the world under its spell. But beneath the enchanting facades and winding canals lies a deep-seated problem that threatens its very existence: the aqua alta. Known as high water in Italian, the aqua alta is a natural phenomenon where unusually high tides flood the city, turning its cobbled streets into shallow lagoons.
Italy is suffering its worst flooding in more than 50 years. At least 2 people have died.
Driven by a combination of factors such as rising sea levels, low atmospheric pressure, geological subsidence, and strong winds blustering in from the Adriatic Sea, the aqua alta has become an increasingly urgent issue for the Venetian people. Historically, these events have been sporadic, occurring only a handful of times each year. However, in recent decades, they became far more frequent and severe, with floods occurring more than 60 times a year. 2019 in particular brought with it the worst flood in over 50 years, causing up to 80% of the city to become submerged. Beyond the inconvenience and economic strain caused by the flooding, the city's remarkable architectural and artistic heritage is also under grave threat. Historic structures adorned with priceless artworks suffer from saltwater erosion, and foundations of ancient buildings are gradually weakened, putting their long-term survival in jeopardy. Preservationists work tirelessly to restore these treasures, but without a comprehensive solution, Venice's rich cultural legacy remains in peril. This is where MoSE comes in, Italian for Moses and short for Modulo Sperimentale Elettromeccanico, or Experimental Electromechanical Model, a $7 billion flood blockade system finally up and running 18 years after construction began. The system consists of 78 gates, each 20 to 30 meters long and 20 meters wide, which rise up from the water when there's a threat of flooding. These gates are distributed in 4 lines at the 3 entry points to the Venetian lagoon from the Adriatic Sea. The 2 southern inlets, Malamocco and Chioggia, have 1 barrier each, but further north in Lido lies the Treporti Inlet, the widest channel by far, with a seabed that varies in depth from 6 meters to 12 meters. Rather than building a massive barrier of varying height, an artificial island has been constructed to divide the inlet in half so that 2 smaller barriers could be built. And yet, when the barriers are not in use, you don't see a thing. Unlike flood barriers in Northern Europe at a much greater expense, the MoSE was designed to be invisible when the barriers are not needed. The gates are filled with water, submerged, and sit in massive reinforced concrete housing, allowing boats to sail by unimpeded. To raise the barriers, compressed air is pushed into the gates, forcing the water out, causing them to turn on their enormous 42-ton hinges and emerge from the lagoon. Once raised, the barriers are elevated enough to resist even the most tumultuous of conditions. They can hold back tides as high as 3 meters and are designed with climate change in mind, with up to 60 centimeters of rising sea levels accounted for. Once the tides subside, the gates are filled with water again and lowered back into the concrete housing. Raising them takes about 30 minutes and the lowering process about 15 minutes. After decades of initial controversy, the building of the MoSE began in 2009, with the last fin installed in June 2019 on the Lido side of Tripoli Island. The Venice lagoon is notoriously shallow. The depth averages out at just 1 meter. However, the inlets from the Adriatic are much deeper. Malamocco, the entrance to the industrial port, is 14 meters deep, for example. Although they didn't alter the depths of the inlets, engineers excavated the seabed along all three to make room for the concrete cases, which fit flush alongside the seabed. The 14,000-ton cases were cast in concrete on the mainland, then floated into position and sunk beneath the water, while the debris removed from the seabed was used to build the island of Tripoli, which houses the central hub and headquarters of MoSE. The concrete used for the housings was a specifically formulated mix designed for durability, strength and resistance to the corrosive effects of seawater. The housings was constructed using reinforced concrete, which involves embedding steel reinforcement bars within the concrete to enhance its tensile strength and structural integrity. Each housing is a massive 20 meters in width, 4 meters in height, and weighing over 20,000 tons. These colossal structures were built to withstand the powerful forces of the Adriatic Sea. Due to their immense size and weight, each housing was constructed in sections. Specialized heavy lifting equipment and cranes were used to carefully transport and position the sections in place, with hydraulic dampers laid on the seabed allowing the housing to be safely lowered. The construction of the housing followed a carefully orchestrated sequence. This involved building temporary cofferdams around each housing site, dewatering the area, and then proceeding with construction in a controlled, dry environment. Inside the concrete chests sit the metal floodgates, treated every 3 months with an anti-corrosive non-toxic to preserve the lagoon's ecosystem. Each of the 78 barriers is a uniform 20 meters wide and varies from 20 to 30 meters in length, depending on the depth of the water. Of course, projects of this size are rarely without their detractors. One of the main criticisms leveled at the MoSE is that the barriers interfere with the lagoon ecosystem, turning it into a pond cordoned off from the natural flow of water rather than a living lagoon. According to Elizabeth Spitz, the commissioner responsible for the project who reports to the Italian government, the barriers were once up for 48 hours simply to test their resistance, and in the future, even in periods where the barriers need to be up daily, it will only be up for around 3 to 4 hours at a time. They've also installed locks at Chioggia and Malamocco to enable some fishing vessels and industrial ships to pass while the barriers are up. Another criticism is the exorbitant overheads. The MoSE costs around $8 billion to build, and accounts from its first year suggest that it cost $328,000 to raise it every time, nearly double the original estimates. The fins must be treated with anti-corrosive every 3 months, and their containers must be dredged twice per season. After a buildup of sand inside them meant that 6 fins could not be lowered during 2020 trials. The containers will need a thorough clean every 5 years. Despite these aspersions, there is evidence that MoSE is working effectively. In November 2021, forecasters warned that water levels might rise 140 centimeters above normal when high tide peaked and strong Sirocco winds battered the Venetian coast. Water at that level is enough to flood 60% of the city, including the iconic St. Mark's Square, the lowest part of the city. Activating the floodgates proved successful in this case. While high tide water levels rose above 130 centimeters in the Adriatic Sea, they reached just 83 centimeters in Venice, enough to prevent major flooding. MoSE has been used several times in recent years as engineers test it and work towards making it fully operational. The floodgates were activated 5 times in 2021 and 20 times in the previous winter. Though MoSE has prevented several high tide floods, sometimes high water has eluded system operators due to inaccurate weather and water height forecasts. For instance, much of Venice flooded in December 2020 after forecasts underestimated the maximum height of a high tide by 5 centimeters, enough to prevent operations from elevating the barriers in time. As the MoSE system fortifies Venice against the rising tides, a question lingers: will it stand the test of time? Its concrete might and clever engineering demand respect, but the evolving forces of nature remain unpredictable. Its success sparks hope, yet challenges persist. Can other coastal cities draw inspiration from this advancement? Or are more traditional systems, such as the Thames Barrier, still the benchmark for flood defense? The MoSE project teaches that proactive measures are paramount, but each locale demands a bespoke approach. Whether the doubters are proven right eventually or not, the people of Venice are putting their trust into the new flood defense system. And in the immediate present tense, that should be all that matters for now. Thanks for watching, and until next time.